Hello, welcome back to More Fun Fixing It. It's 2026 and this looks like it might be my first video of the year. I did try to make another video where I was repairing a 128K plus 2 grey and I failed to repair it. So that will probably be going up as a failed video for my patrons. If you want to see that, you're going to have to pay for my blushes. I will come back to that one though eventually. So because it's just one of those repairs that just made me want to pull what's left of my hair out. Anyway, look, we're here today for this one. This is a ZX Spectrum Plus. Okay, Sinclair released this computer as a kind of a reply to all the criticisms about the original ZX Spectrum's rubber keys not being the best. Okay, I'm quite fond of this, and if you grew up with this one, this is what you loved. And if you got this one, if this was your first machine, I know there are many of you out there that this was your first machine, this is what you loved as well. It's not my favourite thing. It's functional, and I can't love it. I've tried, but I can't. But when this came about, Sinclair put these out as a complete computer, and I've got one. Picked this one up from the Cambridge Bring and Bytes sale, and I'm pretty sure, yeah, this one has an issue 6, the last of the 48K motherboards in it, and it's got an appropriate serial number here in red, as you would expect. This one is an issue 1 ZX Spectrum. That's not the original keyboard, that's a replacement keyboard. You can tell by that bit there, but it is the same color as the original keyboard would have been. The case is definitely the original issue 1 because it's got the hole in it here. And this was donated to me a long time ago by my friend Repairy McRepair Mark. I haven't seen you around for a while, Mark. I wonder if you're okay and if you're still about. Quite a nice lowish serial number in green. These are some people are able to decode these, and I've no idea what. Some are red and some are green, and some are from different countries. So they'll be made in the UK and Portugal and Hong Kong. No, were they made in Hong Kong? Korea, I think one was made. One revision was made in, and where was this one made? It doesn't say where it was made. That's weird. Probably Portugal. So what people did when Sinclair released this new ZX Spectrum with its fancy new keyboard with lots of marketing, they also did an upgrade. So you could take your original 48K ZX Spectrum, skin it, take the insides out and put them into a new case like this. And they were very, very cheap. I put the advert up on the screen if I can find it. And gave you basically a new computer with a fancy new keyboard, which has extra bits on it as well. So it has keys that you didn't get on the original Spectrum. So delete for a start. You have to press cap shift delete on the original Spectrum, and semicolon and quotes, which are important when you want to go load, quote, quote, enter, bang, you're done. On here you would have to go load, symbol shift, quote, quote, enter, and then you're done. It wasn't much hassle, but they also included edit, extended mode, graph, as well as caps lock, which I'm not sure if that's the same thing as cap shift. And your symbol shift is here and here on this one. You've got cap shift over this side as well. A space bar. Oh my God. No space bar on a ZX Spectrum. It's a space key. You've got dedicated cursor keys as well, and a break key up here. I think that's about it, but it required a different type of membrane. This is a simple membrane with 2 halves that just have contacts on each half that press together. This one has a 3-layer membrane, and reverse engineering this is a nightmare. Ask Lee Smith from Lee Smith's workshop. He spent ages trying to do this, and it broke his brain. But yeah, the 3-layer thing is just absolutely crazy. So you will get your 48K ZX Spectrum from whatever issue machine you've got, usually an issue 2. You would take it out, you would plonk it inside this, solder a couple of wires to a capacitor in here if you wanted the reset button to work, which wasn't that important really. And then everything else was exactly the same. You had some nice little stand-up feet to make it a little bit easier to type on. And yeah, a nice, more professional looking case. This one is a bit different. If you look on the other side of this one, it says upgraded. So this is what I was talking about, where somebody's taken their original ZX Spectrum, and it could be any revision, and put it into one of these cases. And most of the pluses that I've seen with original boards in that came with this case have been later ones. So 4S's, maybe a 5. This would be a good place to look for an issue 5, which are super rare, and issue 6s. And you would expect in one with a serial number to find an issue 6, but one with upgraded on the back, you just don't know what you're going to get. So Paul bought this. This is from Paul Universal Retro Boss. He bought this in a bunch of other Spectrums, and he opened it up and went, oh! And here we go. This is what's inside. That is an issue 1 ZX Spectrum. They're not ridiculously rare. They're not issue 5 rare. There are not a huge amount of these out there, and they are much more valuable than a standard ZX Spectrum, especially with the Daughterboard, the memory Daughterboard included on this one. Let's get it out. A quick thanks to PCB Way for sponsoring this repair. I often see here on More Fun Fixing It that sometimes a repair isn't just about swapping a capacitor or replacing a bad RAM chip. Occasionally the original board is corroded, cracked or completely destroyed by an over-enthusiastic repair. When that happens, often the best fix is to reverse engineer it and get a brand new one built. That's where PCB Way shines. You can design a replacement board for a vintage machine, upload the files and have a professional quality replica sent to you in no time at all. It's the ultimate way to save equipment that would otherwise be scrap. And if you're restoring something with a missing trim piece, a broken bracket or even a smashed case, their 3D printing service can reproduce those mechanical parts too. Don't let a bad board end the repair. Check out the link in the description to get your replacement parts made. Thanks to PCB Way. But yeah, this is an issue 1 where someone's attached the capacitor or the bodge to a capacitor that's sitting underneath this heatsink here. This, I think it's C27. It's the reset cap. So it's part of the reset line. You drag it down to, you short it out to ground and it invokes reset. And the Daughterboard on this, come on, this 32K add-on is what came if you bought the ZX Spectrum 48K in the very first instance, the first revision. This is what you would get from Sinclair. If you bought a 16K ZX Spectrum, you would just get this. And then if you wanted to add your 32K to bring it up to spec, you would buy something like this, an add-on RAM pack, and have it wobbling around on the back of your Spectrum, like that. Yep, it does really wobble. I might try that later because I've never plugged it. Well, I'm not going to try it on this one because I'm not going to risk this one. But let's see if this works first. I'm going to put it back in its case for now, clip it into its little standoffs and make sure it's going to work. Now, normally all ZX Spectrums I would composite mod, which entails adding a capacitor down here between the video out of the motherboard and the RCA jack to compensate for some DC offset that you often get. But I'm not going to do that with this one unless, I'll ask Paul what he wants to do, but I wouldn't do it with an original issue 1 ZX Spectrum because I don't think this is the sort of machine that you would buy to use. I think this is the sort of machine you would buy to keep original. So it's probably more appropriate to make sure this works, do as little work to it as possible to keep it as original as possible. Don't want to change any chips unless I have to. I don't even want to change the capacitors unless something is obviously wrong. And I will go around and check them with an LCR meter, just to check if any of them are really high resistance and if any are close to failure. If they are, I'll look at changing them with something appropriate and try and keep it as original as possible. But I want to see if this works. But before we do, never ever do that. Never just switch it on. What you do is go through your initial checks that you always go through. Now I'm going to use my original multimeter. I've got my Bryman multimeter over there, which is great, and I really like it. It's got better leads on it and everything, and it's just a nicer multimeter. But it gives a different reading on diodes, which really throws me, and I can't really tell if the transistors are faulty or not. So I'm going to use my old meter on ZX Spectrums until I've figured out a way of getting around that. So first of all, I'm just checking the resistance on the 7805 voltage regulator here, just to make sure the input and output pins aren't shorted. Now I'm going to check the 12 volts and -5 volts. I think that's the right way around. And the 5 volt lines on the lower RAM, or on the RAM, because there isn't any other RAM attached to this, and none of those are shorted, so that's okay. I do often check the coil, but usually you can find a fault by checking the transistors. If something's gone wrong on the coil, it will show on the transistors. So they're actually showing resistance. They shouldn't show resistance, but this way round they should be. Yeah, they're open loop, open line. And that one is open line as well. That's just a capacitor in line that's charging that up. Now the normally I know where the transistors are. I think that one there is TR. That's TR4. Right, yeah, that's TR4 there. It's a bit confusing. So that one's TR4, and then the first 3 points on that top row there are TR5. So black lead in the middle on TR4. And nothing there, nothing on the other lead, and then red lead in the middle, and it should get voltage drop on that side and voltage drop on that side. That's normal. And then black lead in the middle of TR5, and we get 0.6 that way, 0.6, oh well, yeah, 1.9 that way, and this way. No, that's wrong. Why is that doing that? 1.9 that way. I would expect that to be 0.6 the other way as well. Anyway, there's a little slight anomaly on the reading for the TR5 there. So what I'm going to do is plug it in with the Steam Card Pro so that I can see if the voltages are present, and I can just immediately switch it off, and I'll have it on low current, so it'll be protected anyway. And as long as you don't leave these on, switched on with a bad transistor. Right, so what we're trying to avoid here is a missing 12 volts or -5 volts or 5 volts on the lower RAM. If they're the bias voltages on the lower RAM, they are all required there to hold the voltages at the right levels across the chip. And if they're not, if one of them is missing, then things can get hot quite quickly, and the chip will melt down inside. So I'm looking here at these 4 diodes here: 12 volts, 9 volts, 5 volts, -5 volts, and they're all there. And there was a beep, so the computer is actually running. Let's plug it in and see if we get anything on capture. And whilst that's running, I'm going to actually test the voltage on the lower RAM as well. So I've got a horrible picture. So we've got -4.5, that's fine, that's close enough. 11.86, I got the voltages the wrong way around earlier, and 4.92, that's all fine. And I'm just gonna, just for safety's sake, just have a little look with a thermal camera as well. Make sure nothing's getting silly hot. And it's not. The hottest thing on here is the ULA at about 38 degrees, and that's normal. It's quite cold in here today. My hands are freezing. Nothing is getting silly hot. The LM1889N is a bit warmer than normal, but that's fine. It's working. Well, it might be working. I've got a horrible picture, but that could just need tuning. So I didn't even see if it passed its tests. I'm going to put it onto the other set of tests, and we'll run these ones through. But it's good that the computer is working in 16K mode. Still got to check if this is working. Yeah, it's passed all of those tests. We've still got that horrible blue screen, but we'll ignore that for now. And I've just put my Bryman multimeter into low Z mode, and I'm just going to make sure that this is drained of any voltage before I plug in. I'm just going to be extra careful. If there's just nothing there, that would have just drained. You know, if any of the capacitors had held any charge before I plug this in. So just being ultra careful. I don't want anything attached. It does get caught up. I was getting caught up on the edge connector actually for the Steam card. Okay, well that's in there now. Yep, in all directions. And I'll run the diagnostics again. Blip. Oh, a fail. Following ICs, IC21 has failed. So I'm going to have to work out which one is IC21 on this Daughterboard and swap that chip. That's interesting. There is clearance there to put a socket in, but do I put a socket in this board? I think that's sensible. I know that it's not really in keeping with the originality of the thing, but not. The other thing is it's upside down. It's hanging in a socket. No, I'm going to solder it to the board. I'm going to get a brand new 4164 in whichever one it is that's broken, and that's something I'm going to have to work out which one it is and the orientation of these chips. So these logic chips, there's a couple of logic chips here, and then 8 4164 DRAMs here, and then another then the socket here, then another 2 logic chips here. They're all these are in one orientation, and these are in the other orientation, and those are in different. Oh, it's really confusing which way around this thing goes. Okay, so I've hooked up the scope to the video output now. To see if we can do something about this blue tint. It should be fixable just by tweaking these 2 variable resistors here. And the scope is jumping around all over the place. That's just my inability to use it properly. So now I'm going to do the top resistor here, variable resistor, and I'm looking to make that line thinner. Or as thin as I can. So I'm going to leave it at about there, which is about the thinnest point. And I've already got a better picture. But I'm also going to do the bottom resistor. Let's go in the other way. Oh. I think these spots might be a bit scratchy, but I think that's as good as I'm going to get that picture. Now, I don't know what that's going to be like on the RF signal output. This is something that Paul's going to have to test, because my TV over here has a really poor RF input on it, so I don't trust that. Let's plug in the Steam card again so that I can get some colour on the screen. Yeah, that looks better. It's a bit dark, but that's because of the composite mod, and normally I would be changing TR1 and TR2 to BC549s. If this was having a composite mod, that's what I would do, just to brighten up the picture. But what you can do on your CV is just turn the brightness up. Okay, that's and now we've got the proper colours. We can easily see the problem that this upper RAM board has got. So which one is IC21? That's what I need to know. Which data line is IC21? That would be the easiest way to find out what's going on here. So in the Steam Card Pro manual, it shows the issue 1 lower 16K RAM, but it was not going to show the issue 2 upper RAM because it's not included as standard, I suppose. Maybe it's something that we can add, but I don't think these have actually got designations on. I think they're just chips that are chucked on the board without any IC number on them. So, but an issue 2 and above, the upper RAM, IC21 is data line 6. So if I find data line 6 on the CPU, pin 10 of the Z80 down here somewhere, and then scope that out to find out where, no, because it goes to the, no, that's not going to help me at all, because all of the data lines are all connected. All right, I need to look at the schematics. I don't know why I doubted myself. So the data lines aren't all connected together. The data input and output on each chip is connected together, and all of the address lines are connected in parallel. But each set of data lines, so I think it's these two and these two, each set of data input and output are connected together on each side of the chip, and they're not connected to the next chip, or the one after that, or the one after that. So pin 10 on the CPU, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, should be connected to what the equivalent of IC21 data line 6 on this board. So that one. Those two pins there. This one is IC21, the equivalent of. So I'm just going to put a little cross there. I can clean that off with isopropyl alcohol after. And then heat up my desoldering station. Probably the only time I'll ever do this to I don't know, I might do this again one day. You never know, but I've never done it before. I've never desoldered a chip off of one of these. And these are still, I was wondering if in the early days, Sinclair had just been putting the full spec 4164 RAM chips in here before they made the deal to get these half broken ones. But no, these are the half broken ones. TMS4532. So I'll have to use my old RAM chip tester. I have got some new RAM chip testers to look at, but for this one, I'm going to have to use my old one because I don't know if the new ones are spec to work with this. No, the Pico DRAM tester can handle these now, but I haven't updated the firmware for a while, so I'm going to stick with the old one. Right, I'm going to flow some solder onto the other side, or onto all of these pins, just to make this as easy as possible, as low risk as possible. I'm going to turn my desoldering station down to its lowest setting as well. It's got a new tip and it's brand new feel to it as well because I cleaned it the other day, the desolder station, the Hacko. I've been using a few different desolder stations for an upcoming video, and I'm really excited to share that with you soon on my main channel, More Fun Making It. Go and subscribe if you want to see that. A big roundup of desoldering stations for all budgets. So I've never desoldered anything like this off of one of these boards. I've no idea how delicate these pads are. We could lose some here. This is the worry. So I'm going to be as careful as I possibly can to get this off without damaging anything. So I'm going to start with the heavier pins. That went well. And one thing that's concerning me here is that I know that some of these pads are not connected to anything, and those are the ones that will just float away. So I'm actually just not heating these for as long as I normally would. And I'm going to rely on hot air on the other side to free the chip. Does look like it's done a really good job though. I can't see any solder left on this side. And I'm going to have to be careful because there's bare traces underneath here when I try and lever it out. I'm just going to give it a little, sometimes they go. And I'll just, my little Gadget UK tweak. I think these holes are quite tight. Their vias or the vias are actually very tight. So I'm going to have to heat this with the desoldering station, with the hot air gun. Actually, I'm going to put this in a holder. I said on a live stream the other day that I don't use this nearly as much as I really want to. It's too long. Well, no, that's even floating around as well. Oh, that's because I've got a magnet stuck to the bottom of it. Oh, I'm going to fix this down with some blue tack. Blue tack fixes everything. Apart from my camera angle. There we go. It's cold in here. The blue tack's not doing a great job. Okay, let's try again. It's warming up the area first. Try not to melt any plastic. Perfect. There's no damage on this side, which is where all the danger is, really. I'll inspect the other side. Okay, so now we need to find out if it's working. I keep going back to this chip tester. I've got loads of chip testers now. This one just is so convenient and easy, and it just, all I want to know is if a chip is faulty, you know, properly faulty. Edge cases, yeah, I'll need different testers. Right, 4164, but yeah, immediately dead. That's good. Right, I'm going to keep this one to one side because I need to know why that one's dead. I'll try it in the, actually we can do that now. The Pico DRAM tester. I don't think, I might have updated the firmware, but I don't think I have. So if I just do 4164, just fails. No, it's just an immediate fail, but that could be because it's expecting a half bad chip. Is it that one? Yeah, TMS4532 NL4. It's just failing. Just a broken chip. Okay, well, it was worth looking at. So I have updated the firmware on it. I should use that more. But I have got some new ones coming. Right, so now I need to put in a chip in here. But what do I put in? Okay, right, so I found in my stash, I found 3 chips. Most of the ones I found are actually the ended in NL3, and this needs to be an NL4. So it's a 4132 NL4. I'm just going to check. I've got a few out just in case. Very confusing. They've got a dot on each end, but there is a cut out there as well. It's just a bit rude. And check that. Has failed on 100 nanoseconds, but that doesn't mean much actually. Oh, that's failed as well. Which socket's it saying? Using 4164 socket. That's the right socket. NL4. Okay, that must be a faulty chip. Try another one. That's failed as well. These are all faulty. I'm going to try my other chip tester, because this does automatically detect this type of chip. Okay, it should just give us too good and too bad. I think it's the older, yeah, that's perfect. Let's check all of these. I think the firmware on the Pico DRAM tester just needs to be updated. Again, that one's good. There we go. So you can just see there's 2 red and 2 green, just saying that the upper half is bad and the lower half is okay. Okay-ish. So I'm just going to pick one at random. Are they identical to these? Almost. All right, so these have got date codes on. Actually, that one's got a scratch on it. I'm going to use a different one. These are a bit later. These are 84 10th week, and these are 82 6th week, which stands to reason, really. But before I do that, I'm just going to inspect this top half just to make sure there's no possibility of solder bridges up here. I don't want to run braid over it because it's really easy to wipe these traces off. That looks absolutely fine. They are very small holes, actually, very small vias. Yeah. That's as close as I can get it. It would be nice to have a 1982 chip, but then again, that would probably be a bit more susceptible to failure. So an 84 chip might be a little better for it. Who knows? Right, let's pop this back in and get it tested. Oh, and I've looked on the back, and absolutely no damage on the back either. Okay, it's flat to the board, and here we go. There's not much pad to get your soldering iron onto. If the soldering iron's only touching the leg, the solder doesn't necessarily want to flow down onto the pad by itself. You have to heat the pad and the leg at the same time. If you don't, then you don't often get a very good solder joint. But when these pads are so small, just trying to get the tip of the iron into the right place is a little bit tricky. Just have to take a little bit more care, and I'm making sure that the solder flows down into these vias. So I put the solder in, I'll leave the soldering iron there just for a second after I've finished applying solder, just to let it flow. That one got desoldered as well. There we go. Good as new. For 44 years ago. Near enough 44 years ago. Oof. I'll give it a little spruce up with some isopropyl alcohol, just to remove any evidence that I was here, and clean up these other pads as well. Oh, they've cleaned up quite nicely, actually. There was a little bit of flux on them. This thing is brilliant, by the way. And look, you wouldn't know. Well, you would. If you look really closely, you would know. But this is the important thing on something like this, is making sure it's as original as possible, but also that it works. Let's see if it does that. Goes in there with a nice satisfying click. So it's not going to end up in this plus case, by the way. Paul is on the hunt for an original issue 1 case for it and keyboard. They do come up occasionally without motherboards. You can often get what looks like an issue 1 from the outside. So it'll have the, if you look on my issue 1, it'll have the grey keyboard. There is another difference on the characters of the keys as well that people spot. I can't remember what that is, but this isn't an original keyboard anyway. But the hole on the back is another giveaway. And looking in the back here at an issue 1 board is also a giveaway. But you will often get those cases with an issue 2 in them. So you can get a grey keyboard issue 2. So yeah, it's worth remembering that they're not going to be as valuable. So putting this board into there will make that the complete package. Right, we've got the Steam Card Pro in. Actually connect up video wherever I've put that. Burnt my desk, knocking out the soldering iron there. It's a lovely wooden burning smell. Right, nothing shorting, hopefully. Here we go, upper RAM, yay! If it passes the walk test, it's probably gonna, oh no, it's the March test is the killer one. Perfect. Fully functional issue 1 ZX Spectrum. Well, the issue 1 itself was always functional, but this is quite a nice one. It runs nice and cool. The ULA seems to run, I mean, I can barely feel that's warm, and it's really cold in here. This is a really good one. I need to put that can back on. And that board makes it really valuable as well. Yeah, before I send this back, I need to test whether it will load from tape or not. That might be better for Paul to do that because he's set up better for that. I haven't got reliable software that I can use. I don't often load things from tape, but I will connect this up to a keyboard, disconnect this bit, and plug in a dandinator into an issue 1. It works. Okay, let's put a keyboard in. I'm gonna have to play it like this because the video mod is still in there. Space. So we did a speed run challenge of this on the Retro Hardware Discord, and I thought I had a really good score, but I got completely schooled by 2 people. I can't remember who actually did the high scores, but they absolutely smashed it to the point where they were getting pixel perfect jumps and just embarrassed me, really. So yeah, I don't want to play no more. Oh, damn it. I can't even complete the first level, let alone speed run it. Anyway, that's fixed. Let's have one quick look at my issue 1 before I button that one up. It's got 1 screw in it. I don't have a keyboard membrane in this one. That's something I need to sort out. But I've never switched this one on. I have no idea if it's working. So this is going to be a future video. Plus, I don't have a 32K expansion in this one. It's just the board. And I could use something like this, but it wouldn't be very reliable. I'd much rather have an internal one. So we're going to make one. I've taken photographs and sent dimensions and pinouts. I've buzzed out every pin on every leg and given all of the information to Julian Brown, one of the board folk who hangs around on the Retro Hardware Discord, showing off all of the mad things that he works on. And he has already recreated this board. He's just got one small adjustment to make because the edge of the board was a little bit tight to a trace that was running on this side. So he's got one more thing to change on the schematic, and then I'm going to get it all sent off to PCB Way, and they're going to hopefully send back some boards that I can make up into a brand new issue 1 Daughterboard. That would be cool. Very simple build. It won't be very difficult. It's just a 4 logic chips, and yeah, the 4 logic chips that normally sit up here on a 48K Spectrum after this issue, and 8 DRAM chips, a couple of pin headers to go into these sockets, and then yeah, I'll be able to have my own 48K issue 1 Spectrum with its own 32K Daughterboard. Oh, that's screwed in. Don't want to pull that out. Plus, I've never used this before. I'd like to have a little game on it. I'm sure it'll work. It'll be fine. Okay, right. I'm not going to do anything with this one now. Let's put that one away and leave it for the next one. Thank you for watching. If you like my videos, maybe subscribe. That would be nice. Maybe leave a comment. Maybe hit the like button. If you really, really like my videos and you want to support my channel, so you can go and do that on Patreon. There's a link in the description, and Patreon members get early access to videos and access to a special More Fun Making It and More Fun Fixing It only channel, Discord, Patreon only channel on the Retro Hardware Discord, and where we can talk about everybody else behind their back. It's not, it's just somewhere where I share clips of videos and things and behind the scenes stuff, and what's going on in the workshop, which I just share with my inner circle members. But if you want to be part of that, you can sign up with Patreon. There is a free tier on Patreon, and I do often share things, updates and things on the free tier. I also put posts on there to notify when public videos go public, so that people can find them without relying on the YouTube algorithm. But other than that, if you've just watched this video and enjoyed it, that's great. Thank you very much for watching. I'll see you in the next one. Bye. Oh, I've got some more issue 1s coming soon as well. Broken ones. Yeah, you heard me.